Hello everyone, on behalf of my team, I, Zainul Abidin, from Universitas Brawijaya, would like to present our research which the title is Wireless Sensor Network using nRF24L01 Plus for Precision Agriculture. Coming to the introduction. First, the precision farming or agriculture is a smart concept that allows farmers to manage the spatial and temporal variability of agricultural crops. One of the pivotal advancements in this domain is the application of wireless sensor network or WSN to monitor and manage agricultural fields with a high degree of precision. Most WSNs are built using internet connection. There are several network topologies available for the WSN. However, in some cases, agricultural fields are not covered by internet connection. Internet-free based communication is needed to build the WSN in this situation. So, in this research, we delve into the convergence of wireless sensor networks and precision agriculture through the lens of internet-free module, for example, an nRF24L01 plus transceiver module. So in here we explore the technical aspects of deploying such network, including hardware considerations, communication protocols, data management, and power management. Furthermore, the module, this is the nRF24L01 plus based the WSN is also examined and compared based on two network topologies. Coming to the research method, in here, this figure shows the WSN illustration. So, node 0 serves as the sync node and server. In this case, this node receives all the reading data from the sensor nodes, which is then stored locally. Meanwhile, the nodes 1, 2, 3, and 4 act as sensor nodes responsible for sensing some precision agriculture parameters such as temperature, air, humidity, and soil moisture around the nodes. The sync node receives and collects data from other nodes, storing it locally in CSV files and also in a database. Therefore, the sync node remains active 24 hours a day for ensuring the WSN works properly without losing any data. So, this is the sync node block diagram. The sync node was built based on the block diagram in this figure. The Raspberry Pi 3B is used as computing subsystem of the sync nodes. Furthermore, nRF24L01 plus PALNA was attached to realize its communication subsystem. So this is special for the sync node. And then, on the other hand, we have the sensor nodes here. So the sensor node consists of Arduino Pro Mini as a subsystem of computing and nRF24L01 plus as subsystem of communication. Another one is subsystem of sensing, which consists of DHT11, which is digital temperature and capacitive humidity sensor, capacitive soil moisture sensor, and voltage sensor. So this is the realization of the four sensor nodes in here. Next, we talk about the flowchart of the sensor nodes and flowchart of the sync node. The left one is the sensor node, and then the right one here is the sync node. Or both of them are start with network connection creation in here, because before we start the WSN, we have to make sure all the nodes are well connected. And then this is the result and discussion. First, we did experimental about the soil moisture sensor. So in this case, the figure shows the output voltage value of the soil moisture sensor becomes smaller as the water percentage in the soil increases. It means that the moister the soil, the smaller the output voltage of the sensor. So we conclude these sensors can work properly. Next is about the experiment of temperature and air humidity sensors. The experiment was conducted by comparing the sensor's output values with the output values read on the other temperature and air humidity measuring instruments. So in this case, the instruments are considered to be the true values in order to calculate the error percentage. And then finally, from the experiment result, we know that the most of the average error percentage of the temperature and air humidity are less than 5%. As you can see, some of the sensor nodes produce more than 5%. In this case, we find in here there are 11 and so on, and I think we will consider about using another high quality sensor in the future. And then this is the voltage sensing. The voltage sensing was evaluated by conducting some experiments by comparing the sensor output voltage values with the value read on the voltmeter. The voltmeter was considered to be the true values, and the sensor worked good with small error percentage, as we can see in these tables. And then the next result is about network topology. So as we can see in here, there are two network topology. So as we can see in here, there are 3 mesh network topologies. Dynamic addresses in a mesh network topology mean that when an error occurs on a sensor node which causes the network route to be damaged, or other sensor nodes can reconnect and create a new network route. In this case, the mesh topology was proved to be better than the tree topology in the case of this situation of the WSN. And then this is according to the network topology, according to the flowchart of creating mesh topology data root of switching node, the left one, and then the right one is the flowchart of creating mesh topology data root of sensor node. And then this is the broadcast pole process during initial network creation. The blue one is the success one, and the red one is the failed one. So as we can see here, as is previously mentioned in the introduction, this is the such as the WSN illustration. And this is the address request process during initial network creation. This is the data transfer using scenario 1. As we can see, when the node 1 transferred and or sent data into node 0, which is a sync node, in here, as you can see, the sync node will send the ACK signal acknowledgement until the node 1 receives. Second scenario in here, as you can see, when ACK is not well sent to the node 1, so then the node 1 will resend the data into the sync node until the correct ACK well received by the node 1. The second scenario is in order to make sure that I was received successfully. The next result is about round trip time in here. The testing is carried out by measuring the time required for one node to send data to another node until it receives a reply message or acknowledgement (ACK) from the destination node. In this test, the sync node serves as the data receiving node and 4 sensor nodes serve as data senders. These figures indicate all nodes perform high stability in transferring data. To be noted that in this experiment, we just use 1 meter different distance between the nodes. And then, next is about the WSN performance, which is confirmed by overall system experiment. All program runs with the sensor nodes data sent once a minute. The sensor node will activate sleep node when not sending data. Mesh topology was used to conduct this experiment because previously the mesh technology has superior result compared with the tree topology. The sync node has successfully saved node ID data, air temperature and humidity, soil moisture level, soil moisture voltage, and battery voltage into a CSV file. As you can see in the upper table in here, this is the CSV file, and then it was uploaded to MySQL database, as you can see in the lower data in here, lower figure here. And the figures confirm that the data occurs every 1 minute as planned in the program. The sensor node is designed to go into sleep mode when it is not actively collecting, processing, and sending data. Node power consumption was measured based on the voltage and current. The current itself was measured by current sensor, which is INA219, and the sleep time of the sensor node is set to be 8 seconds. In this case, distance of 1 meter was still applied, and then the longer distance may cause more power consumption. The node in send mode consume more power than in sleep mode, as we can see in this table. So the send mode in here consume more power than the sleep mode. Coming to the conclusion, the WSN based on nRF24L01 plus has been proposed and examined experimentally. The sensor nodes successfully send and the sync node successfully receive, process, and save the data. The prototype can work properly with limited sensors and distance. Mesh topology considered more suitable for this condition because of its dynamic network address. In the future, for the future work, advanced research to improve performance of the WSN with longer distance and better quality sensors for more agricultural parameters is considered to be the future work. Human interface to display the data on smartphone or personal computer and control system are also required for further development. Solar panel based battery charger for sensor node will also be developed in the future. Thank you so much for your kind attention. This is the end of my presentation. Thank you.